Next, we're going to go ahead and mill this part to length, okay? So I want to go over very quickly how I have this in the vise and tell you a little bit why. So what I've done is I already know we started from this side because this is our smaller 3/8 hole, so this one was already cleaned up. And I need to cut any excess material off of the other side. So I want to make sure that I put my clean end in the jaws and make sure that my end that I want to mill is exposed so that I can get to it with the end mill cutter. Now, I put it back in the same configuration to where I have the most clamping as possible. And also what I did is I wanted to make sure that, again, I had enough. I knew that my hole feature was not going to be, I wasn't going to machine off any of my hole feature, so I wanted to stick that out of the part. Now, why did I choose to stick it out this side? Because I could stick it out of the other side. Well, it's very simple. When you come back and take a look at the controls, you'll notice, first of all, that a lot of the mills only have the X-axis control handle or X-axis wheel on the right-hand side. So if I want to try to mill on the opposite side over here, I have to stretch a long way to reach this and be able to view my part. So I find it much easier to mount it on this side of the vise. That way I can get to my handles, and I'm much closer to where my DRO is, and I know where I'm actually cutting. So something else that I want you to take note of is also how I mounted the end mill in here. Now, if you'll look very closely, you'll see that right here is about the clearance for the chips, and the cutting starts right about here, but you notice that none of that is up there. So that cut, okay, is outside of where the spindle is. So the spindle or the collet is actually holding on to as much material as possible. The next thing you'll notice is that everything is so high on this. And the reason being is because I have brought my quill all the way to the utmost position. By doing that, I create more rigidity with the machine tool, and it's not going to get as much vibration and allow me to take a heavier cut with less side effects from that. So what I've done is again, took this all the way to the top. I locked this in place, and then I brought the knee up using my knee handle here, and I raised it up, and I got my end mill to where it's cutting. Now, if you look at it on height-wise, I'm right about in the mid of where the cutting range is. You can go a little higher if you want, but this is suitable for what we're doing here, okay? So this is how we're going to start with this process of cutting it. Now, we know we have some excess material on there, so what we need to do is find ourselves the baseline, and here's how we're going to do it. We're going to go ahead and turn this thing on, and we're going to start driving. We're going to come up here, and we're going to go over. Now, when you look at it from this angle here, you're going to notice that I'm just on the very edge of the part, okay? So what that means is that I'm not going right in the middle. I don't need to do that. I'm going to go to the edge of the part, and then I'm going to start bringing my X over, and I'm going to bring it over ever so slightly, and I'm going to be very, very cautious, and I'm going to watch it closely, and I'm going to listen, and I can hear it. So I'm going to stop there, come out, and I'm going to actually take this and bring it off my part this way. Now, why did I bring it off the part this way, you might ask? Well, the reason being is because, let me shut this off so you can hear a little bit better, is because the rotation of the cutter in regards to the direction of cut, this is a conventional cut right here. It's best for steel. If you do a climb cut, and that would be starting over here, having the cutter spin this way, and it's like climbing across the part, what it can do is it can actually overrun the machine and cause some damage to tools. So this is why we're always going to be cutting in this direction right here, and that is you're feeding the material in the direction the way the cutter is. And we're going to go through those lessons anyway. So, but that's why we're doing it like that. So now that we have where this machine is on the X, I'm going to go back over here, and I'm going to simply go X ab set on this particular machine, and then I'm going to go ahead and run it and see where we're at. Very little lube right on the face of that. And cut that. And I'm going to go back across nice and slow. And I'm going to go back one more time. And the only reason I'm going back one more time is because I'm going to go ahead and bring this thing all the way out to where I can work with it. We're going to stop right there. and I'm going to switch this over, and I've already got my set. So I'm going to turn that off right there. And then what I'm going to do is use a series of chip brushes and rags to be able to clean this up a little bit here. Okay. Then I'm going to use my calipers, and I'm going to take a measurement. Okay, so it's evident that I've already been doing some cutting on this project, but I'm at 3.709. I'm going to make sure that I kind of push lightly but gently rock these things to make sure I'm getting the right measurement. So 3.709 is actually what I have. So 3.709, and I need to get down to 3.696. So I have a couple different ways of doing this. What I can do is actually just do the math, or I can actually put into the DRO what my dimension is and then go down to the dimension that I'm supposed to be at. What does that mean? Okay, well, let's do this again. Let's go back to 0. All right, and we're going to go to Define here, and then we're going to go right back to 0, where we are. That's where we took the cut at, right? So by going back to 0 right here, I said I had 3.709, so I can simply go X 3.709, and then I can add set. So now that right there actually represents how long the part is. So if I want 3.696, well, very simply, I can just dial this to 3.696, okay? This isn't the only way of doing it. If you want to do the math, that's completely fine, and say that, okay, 3.709 minus 3.696 is this, and then I'm going to take a little bit here or there. That is completely suitable to do so as well. So anyway, once we've done that, we're going to go ahead and turn this back on. And I want to stick to around 10 thousandths at a time, okay? So I'm going to go to 699, okay? And I'm going to go ahead and make my cut. 10 thousandths is more than enough for doing this, and especially it kind of breeds, with the amount of material left on this, it breeds repetition, which is very good for kind of getting an understanding and a feel for what's going on. But again, our number is 3.696, so I'm going to go ahead down there to that right now. 3.696. We'll back this up just a hair, because remember, I want to put just a little bit of cutting fluid on there to keep the build-up edge from happening. And I'm going to go across this. And back. Okay. So now what I'm going to do is I'm going to go ahead and drive this out of the way. All right. And the reason I'm driving it out of the way is, again, so I can get my calipers on it. So we're going to go ahead and turn this off and use a series of chip brushes and the rags themselves. And after we're clean enough, we can feel it with our fingers. And then we can make sure our calipers are clean and we have clearance. And when we go over to measure this, very simply, I am at exactly 3.696. Okay? So that's how we're going to get that together. Again, no matter what method you use, whether you type in what you actually have, you know, that represents the length, and then go back from there until you get your what your print is calling for, or you can say, hey, I have 13 thousandths to take off, and then set it for 0, and then just dial it in 10 thousandths at a time until you hit 13. That's also a suitable method of doing that.